Section 13.1.28. One of the biggest factors in determining the value of a home is the square footage. The accompanying data represent the square footage and asking the price in thousands of dollars for a random sample of homes for sale. We're going to complete parts A through H. First thing is, what is the explanatory variable? Well, the value of the response variable can be explained by the value of the explanatory variable or the predictor variable. Determine the goal of the study and identify the variable that may affect the response variable. In this case, the explanatory variable is the square footage in order to get the asking price. Okay, now we want to draw a scatter diagram of the data. So if we open up this data into StatCrunch, we're going to go to Graph and select Scatter Plot down here. And then we're going to put the X variable to be the square footage X. The Y variable is the asking price. And then we're going to select Compute. And so here is our graph of the scatter plot. So if we take a look at that here, there is the graph of the scatter plot. In part C, we want to determine the linear correlation coefficient between the square footage and the asking price. So in order to do that, we're going to go to Stats, Summary Stats, and then select Correlation. So we're going to come back here, we're going to go to Stat, Summary Stats, and select Correlation. And then we're going to select both of these and then select Compute. And you can see there is our correlation, which is 0.9237044. So there is our correlation. And so we would say the following. We would say the linear correlation coefficient between the square footage and asking price rounded to 3 decimal places is approximately 0.924. Now, is there a linear relation between the square footage and the asking price? Now, to test whether the correlation between the explanatory and response variables is strong enough to conclude that there is a linear correlation, we want to determine the absolute value of the correlation coefficient. If the absolute value of the correlation coefficient is greater than the critical value for the correlation for the given sample size, then a linear relation exists between the two variables. Otherwise, no relation exists. Now, we need to find the critical value for the correlation for the sample size where n is equal to 9. Because our sample size is 9, okay? So therefore, we're going to use the table of critical values for the correlation coefficient. So if you take a look here, if we take a look at 9, down here 9, we get a critical value 0.66. So if we take a look at 0.66, which is the critical value, so we know the linear correlation from our previous step was 0.924, and it's greater than the critical value here when n is equal to 9 of 0.666. So therefore, since the correlation coefficient is greater than the critical value, there is a linear relation between the square footage and the asking price. Okay, now we want to find the least squares regression line treating square footage as the explanatory variable. So we're going to open up StatCrunch, and what we're going to do is we're going to go to Stat, and we're going to go to Regression and select Simple Linear. We know that our X variable is going to be the square footage. We know our Y variable is going to be the asking price. And then what we're going to do here at this point is just select Compute, and then it's going to give us the entire data of what we need. So I took this information and I copied it here. So here is our simple linear regression information, and here is our data. So what we want to do is the least square regression line is the following. Well, we can see that we have the line which is here. Okay? And so we can see that y hat, which is going to equal 0.06778, which is the slope times the value of x, plus the y-intercept, which is 84.25 rounded to 2 decimal places. So therefore, there's our least squares regression line. Okay? And now we want to interpret the slope for part F. So interpreting the slope, looking at our line, here's our slope, which is 0.06778. So for each square foot added to the area, the expected asking price of the house will increase by $67.78. and that is $0.06778 thousand. Next question is it reasonable to interpret the Y-intercept? In general, to interpret the Y-intercept, the Y-intercept is the value of the response variable when the explanatory variable is 0. To interpret a Y-intercept, 0 should be a reasonable value for the explanatory variable. The regression model should not be used to make predictions outside the scope of the model. Outside the scope of the model refers to using the regression model to make predictions for values of the explanatory variable that are much larger or much smaller than those observed. This is a dangerous practice because one cannot be certain of the behavior of the data. Since a square footage of 0 is not reasonable, it is not appropriate to interpret the Y-intercept. Part H, last part. One home that is 1,094 square feet is listed at $189,900. Is this home's price above or below average for a home of this size? Well, we're going to substitute the value of 1,1094 into the equation of the least squares regression line and find the predicted asking price for a home that is 1,094 square feet. So the predicted asking price for a home that is 1,094 square feet is the following. So here's our equation. We're going to substitute x to be 1,094. And so substituting x to be 1,094, multiplying it by the decimal and getting 84.25 gives us 158.401. So that is approximately $158,401. If we compare $189,900 and the value of the predicted asking price of $150,401, since the value of the predicted asking price for a home that is 1,094 square feet is less than the observed home's price, this home's price is above average for a home this size. Now, maybe there may be some reasons for this price. There are some factors that could affect the price, including location and updates such as thermal windows or a new siding.